The table above gives selected values for a differentiable and increasing function f and its derivative. If g of x equals the inverse of f of x for all x, which of the following is a correct expression for g prime of 0? So if we take a look at our table right up here, we have a list of x values, a list of f of x values, and a list of values for the first derivative of x. What we don't have is values for the first derivative of g of x. Okay, but let's just get a little reminder of what the inverse function means, just generally speaking. So what the inverse function means is if I have g of f of x and g and f are inverses, then I will just get x as my output. Similarly, if I have f of g of x, again, f and g are inverses, I will also get just x as an output. So while we don't have g prime of x, we can use one of these two and the chain rule and figure it out. Okay, so I'm going to go ahead and use my function composition on the right here, because if I'm trying to get g prime, when I do the chain rule, I'm going to have to take the derivative of the inner function. So inner function's g, taking the derivative of that will give me g prime. All right, so again, this is just based on our definition of what an inverse function is. So let's go ahead and take the derivative of both sides. So the derivative of f of g of x, well, following our chain rule, that is going to be the derivative of our outer function, so f prime with respect to our inner function still, so f prime of g of x, but then we need to multiply by the derivative of our inner function, so g prime of x. And what is the derivative of just x with respect to x? Well, it's 1. Okay, moving right along. Let's see. So I need to know, what's g prime of x? So let's get g prime of x on its own. I'm going to divide both sides by, and let's space this out a little bit. I'm going to divide both sides by f prime g of x. Okay. By f prime g of x. And I'm going to end up with g prime x equals 1 divided by f prime of g of x. Okay. But we don't want just g prime of x, although this is helpful because this is general form when you're taking the derivative of an inverse function. But we want to find specifically g prime of 0. So let's go ahead and fill in our values. So g prime of 0 equals 1 divided by f prime of g of 0. Okay. What is g of 0 though? Because we don't have g up here. We have f. Well, I know that f of -4 equals 0, which is according to my table right here, right? F of -4 equals 0, which means that g of 0 equals -4, because they're inverses. I'm just switching my inputs and my outputs. So g of 0 is really, this part right here is really -4. So let's go ahead and fill that in. G prime 0 equals 1 divided by f prime of, again, -4. Okay, and right, we actually have that value right here. G prime of 0 equals 1 divided by f prime of -4. But just so we can double check that we solved it all the way, let's actually find the value of f prime of -4. Just looking up at my table, f prime of -4 is going to be 1. So 1 divided by 1, whoops, my equal sign, there we go. And we'll get g prime of 0 equals just 1. All right, hope that helped a little bit. Again, as I said, this right here, g prime of x equals 1 divided by f prime of g of x, is just the general form. So if you ever come up against a question like this in the future, you can just try to memorize this or know that you can derive it from the chain rule. Either way will work. All right.